Today we will discuss about a linear prediction filter and its application. So we have studied what is linear filter and linear prediction filter, forward linear prediction filter and the reverse linear prediction filter, and it is major cause for it. And then we also have come across a glimpse we have given for a cascade combination of both forward prediction filter and the reverse prediction filter. In nutshell, if you want to convey the prediction filters in general, it is mainly meant for a certain operations, for compression as well as the reduction of the input signal as well as the suppression of the noise. In what way we need to perform it and what type of filters we are going to adopt it to the given output signal in match with the input signal. Output matches with the input. If not, what kind of the corrective measures we are going to ensure to do such applications. So here we go for a system application identification. It is an experimental approach for modeling a process. So whenever you want to build a particular system, we need to go for this kind of an experimental approach. It normally involves a certain prerequisites. They are experimental planning, model structures, what are the parameters we are going to estimate, and then the model validation. So it has to go on these particular stages, and then it has to come into the come in the form of existence. So experimental planning will schedule, plan and think whether the process requires what and what, and if the process requirements are fulfilled, then what type of a model structure we are going to select. And once a selection of model parameters have been done, what kind of a parameters we are going to estimate to fulfill the requirement which is proposed in the initial stage of the statement, and then we will go for validation. There are four basic adaptive filtering applications we can find in the daily life. As we mentioned very clearly that the classical approaches of any prediction filter is nothing but class C diagram. You can see an input signal will be directly given as an output, and that particular thing will be taken as a system output 1. If not, we'll go for finding out the error which is produced by means of y of n adaptive filter plus your d of n, or your y of n plus or minus your x of n. That gives the system output 2. So based on these inferences only, we are going to analyze the particular system and then take the corrective measures to fulfill the requirement of the particular sequence. The class 1 is the identification. You can see whether it is the system input, we are going to the prediction filter, and then straight away we are giving to the plant, and then we will check what is the performance of the system. So there are two analyses there, preventive as well as predictive. Preventive is nothing but to prevent a particular system to get completed, to enter into a stage called damage. And there is a word called predictive. Predictive in the sense you are going to predict the system fault well in advance at early stages where the system is getting processed. And such kind of an identification is essential whether you're going for the prognostic form of getting the details. And the system identification is one among the category of the prognostic analysis or approach towards the adaptive filtering process. When we say a particular system, there may or there may not, we have an inverse modeling approach, where the inverse modeling approach will fulfill the concept which goes in line with your prediction filtering, where we will check with the output, and if there is any corrective measures are to be taken, again it will be feed forward back to the input side and verify whether the input matches with the output. If the correlation between the output and the input does not matches, then it deviates. How much amount of it is deviation has been verified it, and the percentage amount of deviation will decides whether it needs to be accepted or need to be rejected, and that is what will be done by using this inference cancellation. So the inference cancellation we can see at the last diagram. So that if it will have a reference signal and then primary signal. So if the reference signal, normally we have a matching filters and all, similar kind of operations we will see here. So if the reference signal and the performance of original signal is matches, then we'll proceed with that. If not, we'll totally go for a filter which will adapt to the changes by the measuring corrective measures which are given as a feed forward back to the network. And if there is any kind of measurements are to be taken, the requirement is to build online transversal filter model for this plant. The model consists of finite number of unit delay elements and corresponding adjustable parameters. The adjustable parameters and the unit delay element will help us to identify the system fault well in advance before the complete system or a process get damaged. When there is no availability of a reference signal is there, then we can call them it is a blind system identification. So whenever the reference here, we call them it as what we know the ground truth. When the ground truth information is not being provided to have a verification or a validation process to be done, so we can say your x is not equal to y or y is not equal to x. Is there any ground truth proof is there to verify or not? And that will decide by you this particular parameter adjustment at all. And if there is no parameter and nothing has been given, then the particular system identification is referred to as a blind system identification. And this is a mathematical notation to further enhance how the processing will be taking place at every stages. If let the available input signal be denoted by a set of samples u of n and u of n minus 1, where n is the adjustable parameter of the model. Right, the input signal is applied directly denoted by en and the yn, and the output is denoted by yn. The plant d of n serves the purpose of the desired response of the adaptive filter algorithm to model for adjustments, where w1 and w2 and w of n minus 1 are the estimated model parameters. And these estimated model parameters are nothing but it being compared with the plant of d of n. That is what we call them as a reference signal. So each and every process will have a reference signal and try to do the comparison. The difference will define you the estimation error, and that error will make us to take a decision whether to go ahead or to find out. So that is the importance in case of your system identification of fault at an early stage to prevent the complete damage of the entire process. Or if it is a nuclear power plant or anything, if you take this will ahead of the particular process. Thank you.